you so much for coming to class. It makes my life better and a more success for you. All right, this is the last section I cover. I do not cover Newton's method. It was not listed on our criteria. It's an option, and I opted out. But next semester, I'm going to include it because look how fast I am. It's you know, I might as well include it. I always think I don't have enough time, but next time I probably will. It's not going to kill you. They review that in Cal 3. It'll come back, but it's minor. It's formula. It's a formula. Okay, here we go. Now, in the last section, we talked about going backwards. In other words, they gave us a derivative, and we discerned from all of the knowledge we've acquired how to structure the more or less type of look of that original function. Now, here we're going to do several things. We're going to cap F. Cap F comes into play a lot in differential equations. Cap F, because you start with the derivative and figure out what the derivative was or could be, or the limitations of that function with a c that moves it up or down. All right, so now we have the word antiderivative, not the derivative. Antiderivative, not the derivative. So we're going backwards again, and we're looking distinct at the methodology of when do I put a plus c and when do I not. Is everybody comfortable with that? Okay, now that's a big thing for me. I always had trouble with the cap F or cap G or cap H because I knew it was a derivative form. Well, why not just say F prime, G prime, H prime, right? Or, you know, coming back to that basic function. But there is more to that in Cal 2. Cal 2 will also deal with cap F in that regard. Why use a cap F? Okay, so we start off with a definition. The definition of cap F is the antiderivative going backwards. That means the basic function, the basic function. This means it does not have the c, which means a movement up or down of the function along the xy axis of f on an interval I if f prime of x is equal to f of x, and for all x in I. Pretty confusing to me. How about you? Everybody good? All right. Well, it says in the next theorem that if we have an f as an antiderivative, basic form of the function, on the interval I, then the most general antiderivative of f is, on I, is f of x plus some constant. And there's the rub. You can keep just the cap F and work with that, and then determine if you're moving it for whatever height you need. All right, so we're going to first look at some constructions of this item. So if we have exponents, let me get my draw. This is kind of thick for some reason. If we have a power as a derived function, then we go in reverse. And that would be to add a power and then divide by that power. Okay, add, because before, if we took a derivative, we would subtract. We would multiply first and then subtract and get the derivative. Well, we're going backwards, so we're going to add and multiply. Divide, sorry, divide. I apologize. I'll get my stuff together in a minute. All right, so on this one, we want cap G of x. All right, well, I'm starting with negative 4x to the 5. I'm going to add 1 and divide by it. All right, because negative 5 and 1 is negative 4. Everybody agree? Right. So our general function that we started with is x to the negative 4. And we could elegantly write it as this, but this is good enough. Questions? Ready then. So if that's true, well, what do I have here? Well, then we want cap h of x. So I'm going to have x minus 5 add 1 and divide by it. And we could see that we would multiply by that negative 4, which makes it a positive 1, x2. Does everybody see that? We've done enough derivatives that you could do that in your sleep, hopefully. All right, well, then we have something like this. And we want cap k of x. Notice, is there any plus c? No. No plus c because they only asked us for cap f or h. And that's that basic form of that derivative that we started with. Is everybody comfortable with that? Okay. Very careful on that. So on this guy, let me make some more room here. Sorry about that. There we go. So in this case, saying, all right, I'm going to have my x to the negative 5 add 1 and divide by it, plus the 3x to the 2 plus 1 and divide by it, and 3x. And it's divided by 1. So that leaves me with cap k of x, the basic form. And if we took the derivative of cap k of x, we would do what we had to begin with. Is everybody seeing that transition? Anyone not? Now remember, before we did it intuitively. I'm trying to be methodical on this one so nobody gets lost. You do not have to do that. You may do it any way you like. Is that clear? Is everybody comfortable with that? I'm instructional mode. All right. So then we come to this guy right here. Now on your homework, you have quite a bit, mainly because you want to see all forms of this. So how do I get 1 over x taking a derivative? ln of x. Good. All right. So automatically, if I have this, I'm not putting it as x to the negative 1 and adding 1 because I'm going to get 0, which is 1, right? So we're not doing all of that business. We're doing ln because that's where we get 1 over x. just making sure that we review all of the things that, boom, you spit out. Right? Thank you. Very good. So this is going to become cap f of x is ln of x. Questions on that? All right. Well, on this one, we have a multiplier. What's my multiplier? 7, right? So we're going to have cap g of x equal to 7 ln's of x. Questions? I could rewrite that as 7 times 1 over x, couldn't I? And you might see it better that way. Now, on this one, we have a value minus that same process that we did. So this is cap h of x is equal to x, right? Because we add 1 to the x to the 0. That's understood. And then we would have minus the 7 ln of x. All right. When I do natural log, I have to ensure that we don't have negative for it. And that must have the absolute value. I added that at the end to tell you that we cannot have a negative there as an output. Everybody comfortable with that? Everybody get? Right. Okay. This guy right here, we need this sheet here. Now remember in Cal 2, you've got to know some of these trig inverses, inverse trig functions, the derivative and going backwards. All right, does everybody see where we are right here? Okay, well, on this problem right here, I have, it's really 3 times the 1 over the square root of 1 minus x squared. Now, in this case, we're looking at either way you want to go, which I'm looking on the first group, and I find it, and it says k squared. Now, I don't have a k squared. What does a k squared stand for on that inverse sign? Critical for Cal 2. What does a k squared stand? Tell me. It's a non-zero constant. God, that's awesome. Oh man, like you blew me away. That's awesome. And that is correct. It is a constant. By that definition, it was, yeah, because it could be a negative. It could be any other aspect, but that was awesome. So we understand then that this one looks like this guy. It's telling you is that that first constant, if it exists, must be a perfect square. That's what it's saying. Everybody breathing? Everybody knows how to read the chart? Chart carefully? Okay. So I know I have that. And they say it's an arc sine, isn't it? And the argument on this guy is the kx. And now they put a plus c, but I think, oh, and when c equals 0, sorry, when c equals 0, so I don't have to put anything.
It's a kx, not x.
I'm sorry?
It's kx.
But we don't, what's k in the problem? What's k in the problem? That's a good question. What's k squared in that problem? Everybody. Thank you. Good. Am I okay? Trig is always tricky.
So
We'll have one. In fact, we have it on the C one. What's K on the C, part C? Huh?
121.
Yes, but what is K? 11. Ah, K is 11 because it's got to be a perfect square. All right? That's a good question. Now we're getting it. We're getting it. Thank you. All right. Also, too, it's they're tangents. Okay, because it doesn't have a square root. Only cosine and sine derivatives have a square root in the denominator. So in this case, we've got tangent, right? Because we're going to look at the tangent guy. And the tangent guy reads this. Now, in this exercise we're doing, our C is 0. Okay? It's stated in the information C is 0. So we're good. All right. So we're going to do the second one. And we don't have a K again, right? What's 1 over 1? 1. So we're good. And we have a multiplier. What is a multiplier? Questions? All right. So on this one, I'm going to rewrite it so everyone's on the same page. All right. So we know it's a tangent. Doesn't have a square root. Tangent. So we're going to have, and this time we have a K. My K is 11. So I'm going to have 1 over 11 tan inverse of 11x.
And question A, what happened to the 3?
Did I lose it? I did. It's there. Thank you. So careful in reading the sheet. I didn't even double look. All right. So this next definition, okay, that had all to do with cap. Cap F, cap K, cap H, and that means that it is the basic function from a derived function without a constant. It's the basic form. Now, this guy right here has the new symbol for antiderivative. Antiderivative. And it states that if f is called indefinite integral of f with respect to x, it is denoted by the symbol like a sideward long s of the function of x dx. Remember, f of x is that derived function, and we are doing an antiderivative. Is everybody comfortable with that? And then it states the symbol is an integral sign. I don't know if that isn't a letter that I know of. The function of f is the integrand of the integral, the integrand, and x is the variable of the integration. All right. So we're going backwards again, and we're doing the math. And in order to remove this indefinite, in other words, there's no parameters of measurement, because we do area under the curve with this. We do other aspects of applications for the integral. So we would have 20x squared divided by 2 plus 3x plus, and Now, do we need a constant or not? Well, in this case, the most general, so we don't need the constant. So I'm going to clean it up. How are we doing? Okay.
What are the rules?
Say that louder for me because I didn't wear my ears.
When, when we're taking the,
Okay, if it's a cap F, cap G, no C. If it's stated most general, it's a cap F or a cap G, no C. Is that better? Now, the ones with a C is after you'll notice how it states in the language. And that's a good, I've always wondered that too. Well, it's going to count it wrong if you do it at the wrong spot, because that means you didn't see that it's cap F of X plus C is a completion of what we need to account for all possible functions that can exist. Am I clear? Am I clear? Okay, let's try another one. All right. Well, on this one, I would rewrite it first, wouldn't you? Okay. Rewrite it because I'm going to be adding and dividing, right? Adding and dividing. And again, they're saying most general. So we usually, rule of thumb is put it back in the form that we saw it to begin with. Everybody good? Yes? Okay. Have a couple more of these guys. Now, we can take precedent on anything that has a variable outside and variables within the parenthesis. So my first attempt is to simplify this mess. Is that okay with everyone? Did I do any math that is crazy? Okay, now we're going to do the integral. Oh, let me do that. Stay in my order. And that's to the negative 7. And that's in the same form as it was given to us. Questions? Okay, this next one is our first exposure to trig. And of course, we know to end up with a sign, we started with, thank you. 7 is a multiplier. It's positive, so I'm going to have a negative. Okay, now remember, I'd have to do the derivative of delta theta divided by 5, which would have been 1/5. So it's a division. So 1/5 is a division, so it would be a multiplication. Is everybody comfortable with that? Now remember, d theta, dx, all of those that we're going to dt, all of them are that minuscule little range, that limit range that could happen in doing the mathematics of these functions that we don't really know what they looked like originally. All right. Any questions on that one? Okay. Now we know that the derivative of e to the u is e to the u du, right? And we're going backwards. But we don't add anything to the e to the u because it never changes. We look at the sundry part of the du to deal with this. All right. And of course, you may do this any way you choose. And however your math is 10 times better than mine is half of the time. So, however many steps you want to skip is okay. All good. Again, instructional mode. No man behind or female. Person, no person behind. Questions? I'm sorry?
So like in the homework on the computer,
This is it. Now, it would be a fractional of whatever the original was. Well, these were in negative and a positive, so you leave it. Remember, I made the comment. That's a good question, Aaron. Back to how it was stated. Don't do too much work. However it was stated is what you need to end up looking like. Okay? And this one is a long homework. Remember, you're not going to embarrass me, right? Not ever going to embarrass me in Cal 2. All right. So on this one, they gave us a clue. And part of having mathematics is not always being able to recall identities, although some of you are fantastic. Okay, what this one is we're dividing by, what are we dividing by, guys? Cosine squared all the way across, right? So if I had cosine squared x plus sine squared x, what's it equal to? So if I divide everything by cosine squared, because this is the only one you need, you can do the rest. And then that would give me 1 plus tan squared. And this is secant squared. So once you grapple with doing knowledgeable things to something that's true as a theorem, then you will be successful in anything. But although I got nailed on 1 plus 1 plus tan squared x on one of the homeworks, one of our projects, that was pretty cool. So what am I going to do here? Well, I'm going to first factor out a GCF. And I'm going to substitute it. So that gives me what? Yes? Is it negative because it's sine? That's the only thing. Is it negative? Look on your chart, your cheat sheet. Let me make sure. Yes, it is. No, it's not. It's normal. Oh, it's tan. Oh, function, general antiderivative. It's a tan. I said cotangent. Sorry. Sorry. I gave it to you. The function is secant squared, and the antiderivative, which is what I had, is tangent squared. Tangent. Not tangent squared, but tangent. Sorry about that. I'm going backwards. I lost track. All right. The function y of x satisfies dy dx equals 4x minus 3, and y of 2 is 0. So what we have here is an ordered pair of 2 gets us 0. I always find that weird that they didn't put an F, but they quantified it by listing it as y of x. Okay, find the function that satisfies it. So this means to take antiderivative. All right. So this time we do have a C. So if I have dy dx equals 4x minus 3, then I want the antiderivative, which would give us our y of x equals 2, 4x squared divided by 2 minus 3x plus some constant. We're going to clean up everything, or try to. In case we have 0, 2 for x. Therefore, the function that satisfies the restriction y of 2 is 0 is y of x equals what did we get? 2x squared minus 3x minus 2. Breathing? Nothing hard, really, nothing. And remember, I've given you a cheat sheet, so for your homework, quick and dirty to look. When you get to Cal 2, they will tell you which ones they want you to memorize. My job is to get you to recognize the difference between making a negative exponent versus understanding that 1 over x was originally ln of x. Those type of things is my job. Everybody get backwards and frontwards. That's my job. Is everybody good? Ready then. Well, we have another one, of course. Like I said, this homework is, this homework is long. Wait, that's the whole problem. Sorry about that. No, it isn't. Sorry. I'll get with it in just a minute. All right. We want the initial value, so we're going to use the plus c, some constant that we don't know, but we have parameters for. So we have dy dx equals 6x to the negative 6/7, and have y of -1 is -3. So we have our ordered pair that x is -1 and the output is -3 as our end result. So we're going to take the antiderivative. And what usually happens is the dx goes on the side. So I've been writing it this way, but the dx is on the other side by multiplication. So we're going to have y of x is 6x to the negative 6/7 plus 1 divided by, and now I'm going to have a 1/7, so it's a multiply by 7. Does everybody see that? But I'll do it this way on this problem, plus some constant, because we're doing a bit more on this one. Sorry about that. The x is apart. All right. So we have our general form for all possible functions that have the function start, the cap f of x being 42x to the 1/7. So now we're going to insert what we know. All right. So I'm going to have a -3 equal to 42 times, and I have a -1 to the 1/7 c. Well, the 1/7 of -1, because it's odd, is, thank you. So I'm going to add 42 to both sides. I think I get 39. Thank you. Just making sure. You know how I am. I think I know and don't know. So now I can construct equation that satisfies restraints. So that gives me my function that's a 1,7. And you would check using your calculator by dropping it in and making sure Elma did a good math job. Questions on that? Are we breathing out there? We're fidgeting. I'm going to stop right there. I got to go get my thing and I'm dry. So I'm going to stop right there and then I'll pick up on this after a return.